What's good, math family? In this video, we're going to look at how to solve system of equations by graphing and how to also interpret the solution. So the first problem, these equations are in slope-intercept form, which makes it easier for us to graph compared to standard form. We could get more precise points. So the first point we're going to graph is that y-intercept, which is at 0, -1. And then what I'm going to do is come up with 3 to 4 other points so that we have a solid line. So I'm going to use my slope and go down 2 over 3 to make this point. And then I'm going to go the opposite way and go up 2 over 3 to get the third point. And then once I repeat the process, we're going to have our fourth point. Now, just bear in mind, family, I'm sorry this is not the straightest line, but you guys understand where I'm going for. So that's the first line, right? Now our second line, just remember that our y-intercept is negative. It's -1 over 1 for the rise over run. So after we plot the y-intercept at 0, 4, we're just going to go down 1 over 1 so that we could find other points on the line. And once we go through now and we connect these points, we're going to notice that we have a point of intersection. And this point of intersection happens at 3, 1. So we know at 3, 1, this is when the system of equations intersect and they're equal to each other, right? So for us to check this algebraically, this is what we could do. We could use the substitution method. So if you look over here in purple, right, both of these equations are y is equal to. So if we look at the one in purple, y is equal to 2x over 3 minus 1. I could replace that with the y in the red equation, meaning I could set these two equations equal to each other to determine if this x and y are correct, if this is actually the solution. And what I'm going to do is multiply both sides by 3 so that we could get rid of the fraction. So the first 3 cancels out. We're left with 2x. When we get over to -1 and we multiply 3 and -1, we get -3. And then on the opposite side, this is going to turn into -3x plus 12. So now when I simplify and we add 3x on both sides, we get 5x minus 3 is equal to 12. And then when I add 3 on both sides to simplify the equation further, we're going to get 5x is equal to 15. And after we divide, we know x is equal to 3. So we know the x coordinate is correct. Now if you want to check that y coordinate, let's just plug this one back into equation number 2. So y is equal to the opposite of x, we know x is 3, plus 4. So y is equal to +1. And when we look at this, that is the solution to the systems of equations. So we know only that point lies on both of these lines. And now we're going to go on to our second example. In example number 2, we're going to start off with the equation in red because it's already in slope-intercept form. So we plot the y-intercept at 0, 3. And then now I have a positive slope of 1 over 4. So I could go up 1 and to the right 4. So we have a point right here. And if we go in the opposite direction, then we go down 1 over to the left 4, we should be at that point right there. So now what I do, I'm going to connect these points. Here goes our line for the first equation. Now with the equation in purple, I'm always going to tell you all, family, just put it in slope-intercept form because we'll be able to get exact points, okay? So when I put this over in the slope-intercept form, we know -4y is equal to -x plus 8. Now we know that y has to be by itself, so I'm going to divide every term by -4. And what we get is y is equal to +x over 4 minus 2. So this is the equation we're now going to graph. So same process. We start off with the y-intercept, which is at 0, -2. And then my slope. If they don't put the 1 and they just put x, just remember that basically represents 1. So we have a rise over run of 1/4. So I go up 1/4 to be at this point that you see on my screen, 4, -1. And then we go in the opposite direction, down 1/4 to be at -4, -3. And this one is interesting because once we connect our points, we see that there is no point of intersection. So what does this mean? This means that there is no solution to the system of equations. These two lines are never going to intersect, and there's not going to be a point that satisfies both of these equations, meaning when you plug that point in, the x and y for both equations, it'll be a true statement that will not occur. And if you want to check this algebraically, we could use a substitution method again and set these equations equal to each other. So we have 1/4 x plus 3 is equal to 1/4 x minus 2. So I'm going to do the same process, and I'm going to multiply by 4 to get rid of our fractions. If we don't need to work with it, let's just cancel it. So that 4 cancels out. We're left with just the denominator, which is going to be x. Once I multiply 4 times 3, this is going to turn into x plus 12. And then I go on the other side, fraction cancels out. I'm left with just the numerator, which is x. And 4 times -2 gives me -8. Now, once I combine my variables, right, I subtract the variables, what I notice is that the variables cancel out and I'm left with 12 is equal to -8. So when we look at this statement right here, this statement is not true. So as a result, we're not able to solve this system of equations, and we know they're parallel lines that will never intersect. So that means there is no solution to the system of equations. And we're going to go on to our last example now of this video. Last problem of this video, family, and if you found this video helpful in any way, please smash the like button for us. It really helps us to get this video to more students. So we talked about one solution to the system of equations, right? We've talked about no solutions. Now this third problem is going to be a little bit different compared to the first two. So when we look at our first equation in red, we're going to plot the y-intercept, right, at 0, 2. Then we're going to use our slope, -1/2, to get our next point. So I go down 1/2 to be at point 2, 1. And then when I repeat this process, go down 1/2, I'm going to be at 4, 0. So now we connect these points, right? We got the line for this first equation. And then now we're going to go back to equation 1 in purple. So we notice it's in standard form. Yes, we are going to switch to slope-intercept form by subtracting x. So we're left with 2y is equal to -x plus 4. All right, we need to get y by itself, so we divide every term by 2. Now we know y is equal to -1/2 x plus 2. So when we analyze this equation, we notice that what? These two equations look very similar, if not the same. Yeah, so if we were to graph this equation in purple, we would start off at the y-intercept, which is 0, 2. And if I use my rise over run, meaning I went down 1/2, I'll be at the point 2, 1. And if I did this process again, down 1/2, I'll be at 4, 0. So when we're solving this type of problem, right, let's say we go over algebraically now, and we set these equations equal to each other. So we have -x/2 plus 2, that's the equation in red, is equal to -1/2 x/2 plus 2. Do you notice, right, that both of these equations are the exact same? Even though I put the 1 in front of the x, it's the exact same. So if I subtract 2 on both sides, what we would have is negative x over 2 is equal to negative x over 2. So it's the same thing. If I did this same step with the variables, if I subtracted, or if I added, right, let's put this in red. If I added x over 2 instead of the constants, what would happen is that the x over 2 would cancel out, and I would be left with 2 is equal to 2. So don't think that because the variables cancel out that it's a no solution type of equation. That's not always true. If the left side equals the right side, whether it's a variable equaling the same variable on the other side or a constant equaling the same constant, that means we have infinite solutions. So how can we describe infinite solutions? So two ways. One, any point, any x and y we plug into these two equations, they will always be the same. And what do I mean? The left side is going to equal the right side. All right, it's always going to be a true statement. So if we set them both equal to each other, gave them the same x, they're going to be the same. If we plug in that xy is going to be a true statement, and we know that these two lines are the exact same. They're the same exact line. So really hope that this review on solving system of equations while graphing was helpful for you, math family. Don't forget we had 3 different solutions where there's no solution, meaning parallel lines, one solution, meaning there's only one point of intersection, and then the last one, infinite solutions, meaning that any x or y we plug in is going to be a true statement, and 2, those two lines are identical, meaning they are the same. Thank you guys so much for joining us again on Algebra 1 with Mr. Peters. Comment down below, subscribe to the channel if you have any further questions, or if there's topics you'd like to see in the future.